Hello, today I want to start talking about this new series that I'm going to be working on, which is a general intro to machine learning. When you should and should not use machine learning, the different algorithms that you can find in each of the groups of machine learning, and just what you might find with each algorithm, pros and cons of each, data that comes in and out, how you want to think about each algorithm, and so on. I know I have the template series that I'm still going to be working on. However, I have not had time this semester to work on any of those. And so for the near future, at least, I'll be working on these videos. And in this first video here, I actually want to go over, as the title suggests, the kind of intro to algorithms, sort of. I'm not going to go into anything too deep. I just want to brush on these sort of discrete random algorithms, what's the difference, when to use which. That way you can get a sense of, okay, these are where machine learning algorithms set. That way you can get a complete understanding, in which I'll go into in the next video, of talking about when you should not use algorithms. Machine learning algorithms, to be precise. And so with that, I will switch over to a little new whiteboard that I have. I'm going to be trying this for the first time here, so we'll see how this goes. So the first thing, as I mentioned, there's two different main groups of algorithms that I'm going to at least discuss today, and that is discrete versus randomized. And now with these two algorithms here, the thing to understand is discrete, you're going to be working in a set number of steps. Each discrete algorithm, you can say it will finish in these number of steps depending on your input. And that is the general case for discrete algorithms. And then you have, so then for randomized though, sometimes you might actually not finish them. They might either run forever, or you can set it up to it'll run so many iterations and then fail if it does not find an answer. And so there are those different kinds of randomized algorithms. So for discrete, you need to understand that we'll finish in n steps. We'll say your n time, so or time. And then for randomized, it might run for, say, I'll have two things here. So the first option might run for, we'll say, k iterations. And fail. So it might fail if it reaches all k iterations and does not find a solution. And then, or it just might run forever. And so these are the two main groups of algorithms that you'll run into on a daily basis. So for example, if you're looking at a simple for loop, say if we have a for loop here that's in for pseudocode, maybe running from some integer I from 0 to 10 for that, and we'll say this is exclusive, so it actually goes 0 to 9. In this case here, for this for loop, this would be discrete, and we can say that this n that I mentioned up above would be equal to 9, or you could say constant. It will run in constant time. We know exactly how long it will take, 9 steps, 9 runs, iterations, I should say. So that is for discrete, and you might have different levels of for loops. You might have 4 or more interlocking, or nested, I should say, for loops, or so on. So it can get more complex than this, which would raise the running time. or number of steps that it would take to run. But for the other hand, let's say that, to think of a randomized algorithm and an example of one, let's say that you are running a algorithm that is supposed to find a specific number in a, say, bag of numbers that's from 0 to 100. And say you're asking, okay, try and find number 53. So say we have this, and I'll actually choose a different color over here. Say we have a bag of numbers that's actually a very small bag. Say we have a bag of numbers here that's, say, 0, 77, 22, I don't know, 43, 50, all the way down, all the numbers between 0 and 100. And so I'll just do this 0 to 100 bag. So we have this bag of 0 numbers just between 0 and 100, and we want to randomly pull out a number. We want to look for, say, as I mentioned, find 53. Now, that would be an example of a randomized algorithm. And we could say, okay, we could maybe set K to 20. So it might pull out 20 different numbers, and if it does not find 53, it might fail. Or it might just run, we might just say, just go forever, we'll find one eventually. And then at that point, you might want to find out actually, because the algorithm would not run forever. There would be some probability of it would stop after so much time running. So you'd have to find what that probability in time is. But in all intents and purposes, we can just say that it would run forever for right now. And so these would be an example of your randomized algorithm. And in this case, it might even be worse if we say, okay, when you pick a number out, say we pick out 23, we then put that number back in. So in theory, you could pick out 23 5+ times in a row, and that might happen with this scenario. And so the question is then, well, why talk about this? Well, the thing with these are, you have machine learning algorithms that do fall into either of these two categories. So it is nice to understand and be able to compare one machine learning algorithm versus another. And also on top of that, you have algorithms that are actually direct consequences of machine learning algorithms. So there are algorithms that have been made from the past where we did not know an answer to a solution or an answer to a problem, and somebody used machine learning algorithms to find an answer to that problem. And then somebody, after so many times of answering the problem over and over and over again, we actually found a way to either discretely find an algorithm that discretely answers that problem for us, or even randomly. Because that's the thing we would like to do. We would rather choose a discrete algorithm or a randomized algorithm over a machine learning algorithm. And I'll go more into detail into that in the next video. But just for this video's sake, it's going to be a shorter video, as I mentioned, just to kind of get a general idea of discrete and randomized. And as I mentioned, you might have these different examples here, like the for loop that I mentioned, or the bag of numbers, to give a random example. And they're very toy examples, but they get the point across that you have discrete and you have randomized. These are, as I mentioned, and then we could even say that you might have machine learning that either falls into discrete, randomized, or machine learning based groups, where they'll run for so many iterations and we tell them to stop, or we just have them go until they finish. So with that, all that said and done, that's actually I'll go on here. That's actually all that I had to talk about today. Again, the next video, I'm actually going to be going into why we might want to use machine learning algorithms and why we might not want to use machine learning algorithms for certain cases. Also talk about how you might want to think about data. So just generally looking at data over any algorithm that you might want to look at. And then give an example of, say, okay, you might have this problem. What would you want to do with it? So that'll be the next video that I make in this little series. And as I mentioned, I'll do this next video, and then I'll work over each group of machine learning algorithms, and then I'll go into detail and I'll pick a few algorithms out of each group to then do an entire video over just a general overview of what's good, what's bad about that algorithm, when to use it, when not to use it, and so on. And if anybody would like to have more of these videos where I talk about discrete or randomized algorithms, I can go more into depth on these. If people would like, I can do a separate series on this. That way it gives even a more concrete idea when talking about running all these different algorithms, and why, for example, you might actually need a large supercomputer to run some of these machine learning algorithms, and why you can't just run it on your computer at your desktop at home or a laptop. So if there's demand for that, I will make a different series for discrete and randomized algorithms and go into depth on those and running times and whatnot. But this was just a general overview for all that. So with all that said, thank you very much for watching this short little video, and I will see you in the next one.